Okay, so now we're going to do 8 and 9. Chapter 8 is broken up into two parts, A and B. I'm going to do part B first because that's what will be on the test. Then I'll do part A, which is on the final but is not on this next chapter test. And then chapter 9, which is also on the chapter test. This video and these notes I don't really expect you to get the first time. What I want you to do is just watch the video, fill all the notes out so that you've got them ready for class, and then worry about it as we get in class. We'll do worksheets so that you get what you're doing, okay? But go ahead and fill it out so that you've seen it and got a little bit of idea of what I'm talking about when we go to do it in class, okay? All right, so chapter 9 has to do with hypothesis testing. And hypothesis testing is when we have a hypothesis or something we think is happening, and it's a statistical way of testing that to see if, based on a sample, our hypothesis is correct or incorrect. Like I said, the first one we're going to do is Chapter 8, Part B. So a hypothesis is a claim or statement about a property of a population. It's a guess. It's what you think is happening. The hypothesis test is a standard procedure for testing a claim about a property of a population. The steps for doing a hypothesis test, there are these 5 steps. These 5 steps, you don't need to worry about memorizing this or anything like this. These 5 steps will be written on your test and on the worksheets we're going to do. So you'll know you're going to do each one of these 5 things. And I'll explain these as I'm going through the different slides. 1 second. The very first step is to decide if it's a proportion or a mean. And this is just like in Chapter 7. If it says mean or average, then it's a mean. It's talking about doing the mean of something. If it doesn't say mean or average, it's proportion. Because proportion can be proportion or area or percent, or it can just say 112 out of 542. So look for the words mean or average. If it doesn't have that in the problem, you're talking about proportion. So you would circle one of those two. Then you do labeling, writing out the hypothesis. So, and actually, let me go back. There are 2 hypotheses. One of them is the null hypothesis, which is denoted by H with a little O beside it. I call that H naught. Is a statement that the value of a population parameter, such as a proportion or mean, is equal to some claimed value. We test the null hypothesis directly, and we either reject or fail to reject the null, which I'll come up later, tell you later. The null is always contains equality, okay? And that's written down there in your notes. Highlight those. Highlight H naught and that equal to, less than equal to, or greater than equal to. It has to be one of those 3 things to go with the H naught. The book and my stat lab only uses the equal. They're kind of lazy and don't do the less than, equal to, or greater than equal to. But I like to do those because, we drilled into in Chapter 5 that if it's at least, it's greater than equal to. So it makes more sense to put greater than equal to. Also, the 2 parts of the hypothesis, the null and the alternative, are complements. So it's easier to figure out what your alternative is if you're using greater than equal to instead of just always equal to. The alternative is the other one. It's denoted by H1 or HA. This book used to use HA, now it uses H1. You'll see both in the My Stat Lab. This one is not equal to, so it's either not equal to, less than, or greater than. And which one it is or which one the null is all depends on the problem. The main thing, though, is these are always opposites. They're complements to each other. Either one can be the claim from the problem. Okay, so we're going to practice just that part a few minutes. And these are in your notes where you can write these down. It says write the null and alternative hypothesis and label the claim. Okay, so I'm going to go do this. The first thing I'm going to do is write null and alternative. Okay, null's always on top, the alternative's always on bottom. It says a hospital claims its average ambulance response time is less than 10 minutes. Well, the less than goes with the alternative. It's an average, so we're talking about a mean. And it said it's less than 10 minutes. So this is my claim. Okay? So once you write your claim out, and the claim can be the alternative or it can be the null, once you write your claim out, then you go to write the other one. It's the complement, so it's the opposite. So since this one's less than, this one's greater than or equal to. The other stuff stays the same. It's still mean, it's still 10. Okay, so that's setting up your hypothesis. And this slide just shows it a little nicer and reminds you, remember the book will only put equals. So in the book, it would have null, or my stat lab, mu equal to 10. Like I said, they're just lazy and don't put greater than equal to. Okay, so here's the next one. So whenever you're doing this step, you can just automatically put null and alternative. A consumer magazine claims the proportion of cell phone calls made during evenings and weekends is at most 60%. Alright, well we're talking about proportion this time, so that would be P's. At most 60%, remember at most was less than equal to. 60% is 0.60. So this is your claim. Opposite of less than equal to would be greater than. Oh, and by the way, the reason it had to be up there with the null is because it was less than or equal to, because that's what at most means. Equal to's always go with the null. Opposite is greater than, so the alternative is P greater than 0.60. And again, the next slide. Okay. So hit pause a minute and try this one on your own. Hit go when you're ready to see it. Alright, so null, alternative, mean. So I know that I've got the mean, less than 3, less than goes with the alternative. Opposite is greater than equal to. Okay, now the last one says the study claims that the proportion of cancer patients treated immediately with chemotherapy and radiation that survive is different than 78%. Well, I'm doing step 2, so I automatically do this. It said proportion, so that's P. And then it says is different than 78%. Is different than means not equal to. So anytime you see is different than or differs from or something like that, you want to make sure and put not equals to. Opposite of not equals to is equals to. So anyone can be the claim, and it's important to get this right first because the rest of it depends on this. Now, if you screw this step up, I'll count off for this step, but if you do the rest of it correctly based off the screw up, I won't count off for them. So try very hard to get this step right, but you won't miss the whole problem if you don't. Okay, so the next page in your notes, talks about a p-value. The p-value is the probability of obtaining a sample statistic with a value as extreme or more extreme than the one determined by the sample data. And we do a p-value hypothesis test where we compare it to alpha. P-value is just p. It's probability. It's what we've been finding. We just call it p-value to denote that it's a little different than alpha or the other probabilities we can find. So it's still a probability. We're not going to find it the way we have in the past. We're going to use a calculator function, but we're going to use the calculator function for hypothesis tests. The three calculator functions that you can use to find that p-value are 1-prop z-test or t-test, and these are all under stat test, just like the intervals were. And just like the intervals, they're the same reasons. If it's proportion, you want the one that says prop. If it's mean and you know sigma, you want the z-test. If it's mean and you only know s, you want the t-test. So that's exactly same rules as it was before for confidence intervals. Just we're doing hypothesis tests now. And we're comparing it to a significance level or a level of significance, which is our alpha. And the alpha is also a probability, but it's probability that it'll fall in critical region. Common choices for alpha are 0.05, 0.01, or 0.10. If it doesn't give you an alpha, which is rare, but if it doesn't, just use 0.05 because that's what we've always used for unusual. This is very important. All the important things, if you've noticed so far in your notes, are in great big boxes in bold. The way you do the test, the whole way we decide whether we're going to say yes, our hypothesis is right or no, it's wrong, is if the p-value is less than or equal to the alpha, we reject the null. If the p-value is greater than alpha, we fail to reject the null. And then we use this table here to help us, or flowchart, pardon me, it's not a table. We use this flowchart to help us interpret that decision. So the way this flowchart works, I'm going to go back to highlighter. Okay, here's your starting here, and it says, does the condition contain equality? Well, if you answer yes, that's because your claim was the null. Okay, because remember the null has the three options of equal to, less than equal to, or greater than equal to. So all those are equal to's, so it contains equality. Then you have two choices. Did you reject the null? Well, if yes, you rejected the null, then your conclusion is going to be worded like this. There is sufficient evidence to warrant rejection of the claim that whatever I'm talking about. Okay? If our claim contains equality, but I do not reject the null, I fail to reject the null, then my conclusion starts that way. There is not sufficient evidence to warrant rejection of the claim that. Now it's all these flowery lawyer kind of talk because we're making a guess off a sample. If it's a really good sample, we're fine, but we could be wrong. So we don't just say, yes, it's right, no, it's wrong. You have this kind of lawyer talk in here because you could be wrong. Okay? Then Does my claim contain the condition of equality? If your answer is no, it's because your claim was the alternative. And remember, in the alternative, your choices were not equal to, greater than, or less than. So if you're in the alternative, you do not contain equality. Did you reject the null? If it's yes, that you rejected the null. And I hadn't said that before, but remember, from the slide right before, this would be yes if P is less than or equal to alpha. And so if it is yes, then we start our conclusion that way. The sample data support the claim that blah, 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 blah. If my claim does not contain equality, and remember, you always write claim beside it at the very beginning to help you remember which one was the claim. So if my claim is the alternative and I fail to reject the null, it's your last choice here. There is not sufficient sample evidence to support the claim, whatever. And this is what happens when P is greater than alpha. Okay? So 1, 2, 3, 4, 5, you do all these steps, you follow the things, you get your conclusion off this flowchart, and that's your answer. So that's what we're going to practice in Part B. That's what will be on your test. So let's do an example. It has been reported that the average credit card debt for college seniors is $3,262, with a standard deviation of all students' debt being $1,100. The Student Senate at a large university feels that their seniors have a debt much less than this, so it conducts a study of 50 randomly selected seniors and finds that the average debt is $2,995. With alpha equals 0.05, remember that's your level of significance, test the Student Senate's claim. Okay, step 1. Is this a proportion or a mean? Well, it has the word average. Okay, so since it has the word average, you know then that it is a mean. So you would circle mean. Okay, write the hypothesis and label the claim. So start out this way. From the step before, I know that it's a mean. Now I've got to figure out what that hypothesis is. Okay. It says, test the Student Senate's claim. Well, what was the Student Senate's claim? The Student Senate feels that their seniors have a debt much less than this. Much less than what? Well, it was that $3,262. So the Student Senate thinks that their seniors have debt less than $3,262. That's the claim. All right. Well, less than goes with alternative. So this is what the Student Senate is claiming. Opposite of less than is greater than equal to. So we've written out our hypothesis and labeled the claim. Now it helps to know which test to use to think about what we know from the problem. Okay? So we know we're talking about a mean. The 3,262 I've already used. That's part of my hypothesis, so I'm not worried about that. Then it said that I have a standard deviation of 1,100, And this was from reports that I had before. So this is probably sigma. The student senate thinks it's less, so it conducts a study of 50 randomly selected seniors, so N equals 50, and finds an average debt of $2,995. So since it's from the sample that the student senate does, that would be X bar, and then I know that alpha equals 0.05. Well, if this is indeed sigma, you have a mean, you have sigma, oops, well, that kind of knocked that out, didn't it? Then you know you're doing z-test. Alright, so on your calculator, you go to Stat and over to Tests. Z-test is the very first one. Press Enter. Make sure that it has stats highlighted because we didn't put a big list of data in. Now, that mu naught, okay, over here, I have everything I know so far, okay? So that's from the other slides, all the stuff I already know. And over here is what I'm putting in on my calculator to the left. This 3,262 comes from my null. See how both of them have this little 0, the naught? That's your hint as to where to go look for that. So in the calculator, that mu naught, go look at your null. It's 3,262, so that's what I'm going to put in there for that. Okay. Sigma, I wrote down from the problem. X bar, I wrote down from the problem. N, I wrote down from the problem. So all those were in the reading. Then this less than, so you've put in the sigma, you've put in the X bar, you've put in the N. Then you get a choice of not equal to, less than, let's see, not equal to mu naught, less than mu naught, or greater than mu naught. You're picking the less than because, so you want this one because that's what you've got on your alternative. Okay? So you want the less than highlighted, press enter on it, because that one should always match whatever the alternative is. So with the very first thing in the calculator and with the very last thing in the calculator, you're telling it what test you're doing, and the stuff in between is the data from your sample. Hit calculate, and I didn't get that when I did it. Let me do mine again. Evidently I put something screwy in. Oh, I did. I only put 110 instead of 1,100. Alright, there we go. So on the calculator, it now says mu is less than 3,262, and that you have a z of negative 1.72. That's called, we don't use that to do the test, but in my stat lab, , that's what it wants when it asks for test statistic. Then right underneath that, you see P equals 0.043. Well, that's this P value that we've been talking about. So we did all that calculator stuff just to get this answer. That right there is all you have to do. For the test, you would have told me z-test and what P equals. All this other stuff is just explanation. And I've written all over it. But the two things that you would put down for that step is z-test and p-value equals 0.043. Okay, so then step 4, make a decision about the null hypothesis, compare the p-value to alpha. Well, my p-value is 0.043. My alpha was 0.05. 0.043 is less than 0.05. And per your big box on the page before, if P is less than or equal to alpha, you reject the null. So reject the null. And that's what you'd put down for step 4. Now, following this flow chart, our claim was that it was less than, so our claim was the alternative. I rejected the null, so I'm going to use this one. The sample data support the claim that. So the sample data support the claim that the seniors at this university have a debt less than $3,262. It appears that the student senate was correct. Alright, next example. As I said, if this doesn't make any sense, I don't really expect it to at this point, just go down through, fill these out, make sure you can get the same thing on the calculator as what I'm getting. We're going to do much more of this in class. Okay, a simple random sample of 40 recorded speeds in miles per hour is obtained from cars traveling on a section of Highway 105 in Los Angeles. The sample has a mean of 68.4 miles per hour and a standard deviation of 5.7 miles per hour. Is the mean speed of all cars traveling on Highway 105 greater than the posted speed limit of 65 miles per hour? Use a 5% significance level. Well, it said mean several times. So, in the very first one, you would circle mean. Write the hypothesis and label the claim. So I write that down, I write this down. Now, I got to figure out what the claim is. Is the mean speed of all cars traveling on 105 greater than the posted speed limit of 65 miles per hour? That's what it wants to know. So it's not actually a claim this time, it's a little more of a question, but that's still what I'm wanting to know. So I'm going to use this data to figure that out. Alright, greater than, again, goes with the alternative. Label that claim. Opposite of greater than is less than, equal to. So now I want to figure out what do I know, so I know which test to use. Alright, well I've already used the 65, so I don't care about that anymore. It says a simple random sample of 40, so I know N is 40. is obtained from cars traveling on section of Highway 105. Well, that 105 is just the highway name. I don't need to do anything with it. The sample has a mean of 68.4. So the sample mean is 68.4. Let me try that again. That one didn't quite come out good. There we go. And a standard deviation of, well, it says the sample has a standard deviation of, so that must be S. And then finally it tells me that I have a 5% significance level, so alpha is 0.05. Well, since I have a mean and S, I know that I'm going to do t-test. Alright, so t-test is in the same spot as all the rest of them. I do stats and go over to tests. T-test is the second one. Again, it should be on stats because I didn't put any data in. And just like before, the mu naught comes from H naught. And the last one comes from your alternative. And the rest of the data comes from the stuff we wrote down. So the first one should be 65. X bar is 68.4. S is 5.7. N is 40. And this time I want to do greater than. And hit calculate. So, again, like I said, if it asks for test statistic, which it does a lot on my stat lab, I won't ask you for test statistic on the class test. I'll explain why later. But if it asks you for test statistic, that's 3.77. And then it tells you that your P is 2.68 e to the negative 4. Well, remember that e to the negative 4 means the decimal goes back 4 places. So your p value is this little number, or you could have called it 0 plus. So for step 3 there, the two things you must write down is t-test and what your p-value is. Alright, so now I want to compare that little p-value to alpha. So p, I'm just going to go ahead and call it 0 plus. And alpha is 0.05. Well, 0 plus is less than 0.05. So again, I'm going to reject the null. And I'll end up with pretty much the same thing because the claim was the alternative, and I rejected the null. So I start the same way. The sample data support the claim that the mean speed of all cars traveling on Highway 105 is greater than the posted speed of 65 miles per hour. They won't always start that way. It just so happened that both of these had the alternative as the claim, and we rejected the null on both of them. Alright, so the next one, The company Drug Test Success provides a one-panel THC test for marijuana usage. Among 300 tested subjects, results from 27 subjects were wrong. Use a 0.05 significance level to test the claim that less than 10% of the test results are wrong. Okay, proportion or mean. Well, it doesn't say mean or average anywhere in there. So that tells me, oops, I'm not in my pen, just a sec. That tells me proportion. I could also have gotten that because it talks about a percentage. And the thing of that, I've got 327, 27 out of the 300. But like I said, if nothing else, you know it's proportion because it didn't say mean or average. So, write the hypothesis. So H naught, H1, P, because I know I'm doing proportion. Alright, so what is our claim? It says, test the claim that less than 10% of the test results are wrong. So, less than, alternative, 10%, 0.10. So again, my alternative is my claim. Opposite of less than is greater than or equal to. What do I know? I've already used the 10%, so I don't need to do anything with that. I had 300 tested subjects, so that's N. And 27 results were wrong, well that's X. And 0.05 significance level, so that's alpha. Since it's proportion, I know I'm going to do one prop Z test. Proportion only has one test, so I don't really have to think too hard on which one to use as long as I realize I'm doing proportion. Alright, so if you go into one prop Z test, which as all the rest of them is in stat tests, the P naught, just like before with the ones that had to do with mean, P naught comes from your null alternative, and the bottom question comes from your alternative. So P naught is the 0.10, X 27, N 300. I want to pick less than, calculate, and you get a P of 0.28. Test statistic would be negative 0.58 if it asked for it. So again, the two things you'd write down: what test you used, what you got. So then step 4, what does that mean? Alright, well we got P equals 0.28, alpha equals 0.05. Well, 0.28 is bigger than 0.05, so this time I fail to reject the null. So that's what you put in step 4. So let's see, what does that mean? Our claim is the alternative we're failing to reject. So, our claim is the alternative, fail to reject. So this time we're going to use this last one. There is not sufficient sample evidence to support the there is not sufficient sample evidence to support the claim that less than 10% of the test results for the one-panel THC test are wrong. So we're not supporting their claim. We think it's incorrect. Alright. And then I think this is the last example. Let me look in the notes real quick. Yes, this is the last example for part B. Okay, listed below are the ages and years of randomly selected race car drivers based on data reported in USA Today. Use a .05 significance level to test the claim that the mean age of all race car drivers is at most 40 years. Alright, well, it said mean, so that tells me that's what I'm doing, so I need to write that down, or circle it actually on your notes. Write the hypothesis and label the claim. So always start out the same. That did not work at all. Let's try that again. Now I'm talking about mean. Alright, what the heck is the claim? Test the claim that the mean age of all race car drivers is at most 40 years. Well, at most, if you remember, is less than or equal to, pardon me. So this time our claim is our null. The opposite of less than or equal to is greater than. So there's our hypothesis. And we'll get to the calculator function here in a minute, but we're not going to be able to do that calculator function unless that data is in the calculator. So take a minute and put that in the calculator. Remember, you do that by stat edit. So type all those data values in your calculator. Okay. Now let's figure out which calculator function we're going to use. We know we've got a mean. We know we've got a list of data. We know we have an alpha of .05, and that's pretty much all we know. So it did not give us sigma. So since we don't know sigma, we can't do z-test, so we're going to do t-test. This is very similar to what we did in Chapter 7. When it just gave you a list of data and didn't give you that population standard deviation, you just use t-test. Okay, so t-test, stat over to test, t-test. Now this time you need to pick data because we put a list of data in. It still wants mu naught. Mu naught still comes from your null. And you'll still have to put in the inequality that matches the alternative. So mu naught is 40. Make sure your list is correct. Frequency should stay 1. Then that last one should be greater than. Calculate. And you get a P of 0.997. So for step 3, you would write down t-test and P equals 0.997. Alright, so make a decision. We got to compare P to alpha. And I hadn't said this before, but sometimes people do get this mixed up. The test has the P in front and then the alpha. You're comparing the P to the alpha that way. So you should always put your P value first, then your alpha, so that you're getting the correct less than, greater than for your test. Well, 0.997 is much bigger than 0.05, so we fail to reject. And you should always write null. Don't just write fail to reject, but fail to reject the null. So my claim this time is my null, and I'm failing to. So my claim is the null, and I'm failing to reject the null, so it'd be this second one. There is not sufficient evidence to warrant rejection of the claim. So there is not sufficient evidence to warrant rejection of the claim that the mean age of all race car drivers is at most 40 years. So we basically believe them. Okay, so that's the end of Chapter 8, Part B. That's what we'll work on in the next class. Go ahead and finish these notes out so that you can get that checked off, get them put up into Showbie or show them to me in class. Do not go into my stat lab and start working on 8B. You will only get confused. That Chapter 8 My Stat Lab is all mixed up, okay? So I really just want you to get the notes down and make sure you can operate the calculator. We'll work on it in class, and I'll tell you piece by piece which ones to do in my stat lab. Alright, so the next page of your notes is Chapter 8, Part A. Like I said before, this stuff you have homework on in my stat lab. However, this is not on the chapter test I'm fixing to give you. It is on the final exam. So you do have to learn this at some point in time, but you won't have to learn it for this upcoming test. It's not really hard. It's just kind of a sideways thing. So we're still talking about hypothesis test. And in general, we do hypothesis tests on means or proportions. First step and the last step was always, is it mean or proportion? But you can also do it on standard deviation. So some of the stuff you'll see in 8A have standard deviations instead of means or proportions. In 8A, it'll also ask you whether the test is two-tailed, left-tailed, or right-tailed. This has to do with the other way of doing a hypothesis test, which has to do with extreme regions bounded by critical values. Determination of p-values and critical values are affected by whether a critical region is in two tails, left tails, or right tails. So we need to, for the other test, you have to be able to tell which one it is. Okay? And it's not real hard. It all has to do with the alternative. So if you look at your alternative, if the alternative says greater than, you know you have a right-tailed test. Because basically, just like we did in Chapter 6, if something's greater than, you're up here in this top little part, you would shade off to the right. So because you'd shade off to the right, you have a right-tailed test. And this whole failed, reject, reject, that's the other way of doing this. That's doing this hypothesis test by critical region. If it fell in the critical region, you would reject it. If it doesn't, you would fail to reject. Left-tailed test, look at the alternative. If the alternative is a less than, then you know you have a left-tailed. Because when we colored in less than, we colored off to the left. And then if you look at the alternative and it has a not equal to, then you know that it's two-tailed, because not equal to was when it was in the middle and you had two tails on the ends. Remember, that was your whole z alpha over 2 thing. Okay, so you don't have to worry too much about any of that, except that look at the alternative and it'll tell you whether it's left-tailed, right-tailed, or two-tailed. So on this one, the alternative is less than, so that makes it left-tailed. This one is greater than, so that makes it right-tailed. So try that one. You should have put left-tailed because it's less than. And then the last one that we did before was not equal to, That makes it two-tailed. So to determine left-tailed, right-tailed, or two-tailed, just look at the alternative. They'll also sometimes in the MyStatLab do it the other way. It'll tell you it's two-tailed, and then you know from that that your alternative would have been not equal to. Okay, two other things that you got there in your notes. 8A goes back some to chapter 6 and finding z-scores. And just so you relate that with your level of significance alpha, if you've got a left-tailed test and you want a z-score, you do inverse norm of alpha, 0, 1, because it's z-scores. If you have a right-tailed test and you want a z-score, you do inverse norm of 1 minus alpha, 0, 1, because it's a z-score. If you have a two-tailed test, that's the alpha over 2, 0, 1, because it's z-score. Remember, the two-tailed, you'll have a negative answer and a positive answer. The other two, you'll just have one z-score, might be positive, might be negative, depends on alpha. And then you can also go back the other way. If you know your z-score, you can find your probability or your p-value by using normal CDF. If it's left-tailed, that means you're down there at the lower end of the curve, so you do negative 10,000 to the z, 0, 1. If it's right-tailed, you're on the upper end of the curve, so you do z-score 10,000, 0, 1. If it's two-tailed, you're in between, and you're wanting that in-between value, so you do the negative z, the positive z, and the 0, 1. Okay, that's it for 8A. So like I said, we'll do those in class. We'll go through them very specifically as to which MyStatLab problems to do. And then you forget about it for a little while until the final. Then chapter 9, last 2 pages, or 3 pages in your notes on chapter 9. Chapter 9 is a lot like 8B. It is on your chapter test. We're just doing 2 samples and comparing them instead of 1 sample and doing a hypothesis. So in chapter 9, you're comparing 2 different samples and doing a hypothesis test that way. When comparing 2 samples, you first need to determine if they're independent or dependent, because you do a different test if it's dependent than you do if it's independent. 2 samples are independent if the sample values selected from one population are not related to nor somehow paired or matched with the sample values from the other population. 2 samples are dependent if the sample values are paired. Some examples of dependent is before and after data from when it's the same subject, or sometimes it can be matched pairs where there's some kind of inherent relationship, like they're siblings, or they'll even count married couples sometimes if it has something to do with you being married in particular, where you live in the same environment. So a couple of examples, decide if it's independent or dependent. First one says, University of Arizona psychologists conducted a study in which 210 women and 186 men wore microphones, so the number of words they spoke could be recorded. Well, this is independent because it's just men and women. It doesn't say they have any kind of relationship, so they're not paired in any way. Second one's dependent because researchers conducted a weight study at Rutgers University in which 67 students were weighed in September of their freshman year and again in April. Well, it's the same 67 students in the September sample and in the April sample, so that's in a before-after, so that's dependent. Okay, so like I said, you do them different depending on if it's independent or dependent. If the 2 samples are independent, and this is in your notes, but it's above where that independent-dependent sample was. So if you look, it's about the 3rd paragraph in the notes under Chapter 9 notes. If it's independent, You're either going to do 2-sample z-test, and again, you do z-test if you know sigma, or you're going to do 2-sample t-test, which is if you know s, just like if it was a single sample like an 8b. If the 2 samples are dependent, you're just going to use z-test or t-test because we're going to subtract the data points and compare to 0. We only do means in Chapter 9. So your first question in these won't be is it mean or proportion. It'll be is it independent or dependent. All of them are going to have to do with means. Alright, so your first example there. A headline in USA Today proclaimed that men and women are equal talkers. That headline referred to a study of the number of words that a sample of men and women spoke in a day. Use a 0.05 significance level to test the claim that men and women speak the same mean number of words in a day. So step 1, is it independent or dependent? Well, just like the other example, this is men, women, doesn't say they have any relationship, so this is independent. Okay, now because we got 2 samples, we need to be able to tell them apart. So we need to decide which one is sample 1, which one is sample 2. They already did this in this one because the men, they stuck all those little 1s beside, and the women, they stuck all the little 2s. So this one, they said men were sample 1, women are sample 2. The reason we need to know that is in the next step when we write the hypothesis, we're going to talk about the mean of the first sample and the mean of the second sample. So the mean of the first sample is the mean for the men. The mean of the second sample is the mean for the women. Alright, so hypothesis, well, we're always going to start H0, H1. Now this time, I want to compare the samples. It says, test the claim that men and women speak the same mean number of words per day. So it's claiming that the means from each sample are the same or equal to. So I'm going to write mu1 equals mu2. And I put it with the null because it's equal to. That's your claim. Opposite of equal to is not equal to. So the alternative was B mean 1 does not equal mean 2. So instead of a number, we're comparing the 2 samples. So we're comparing the 2 means. Okay, what do we know? Well, we know all that stuff in that nice little table. And as you may suspect, they don't always give you a nice little table like that. If they don't, write it out yourself. Okay, so you decide which one's sample 1, which one's sample 2, and list things out like that. The only other thing it told us was a 0.05 significance level, so we know that alpha is 0.05. So now we've got to figure out what test we're going to use. Well, we know we're talking about means, so it's either t-test or z-test, depending on, or it's 2-sample t-test or 2-sample z-test, because we've got 2 samples. So it all depends on that standard deviation. Well, your standard deviations for both of them, that's not yellow, is S. So since I have S's and not sigmas, I'm going to do 2-sample z-test. Okay, the same place in the calculator, stat over to test. I just need to do number 3, the 2-sample z-test. Shame on me. I most certainly did. That's not a Z. I hope somebody was sitting there going, why? Why would it be Z? If it's S, that's 2-sample t-test. I apologize. Not paying attention. If it's S, you have to know, and I sat there and said, well, because I know S and I don't know sigma, I should have said, maybe I said when I was talking two-sample t-test, but yeah, that should be two-sample t-test, not two-sample z-test. I apologize for that. Alright, oops, did I write? Alright, so two-sample t-test, when you go into that, so that's the fourth one. Make sure it's on stats. And then you fill all that stuff in. So from that table, the mean of the first sample for the men was 15,668.5. The standard deviation was 8,632.5. I sampled 186 men. Then I move over to the women. Their mean was 16,215. Their standard deviation was 7,301.2, and I sampled 210 women. I'm going to pick not equal to because that matches what my alternative was. Pooled is always no, and then calculate. And you get a p-value of 0.4998. If it asks, the test statistic is a negative 0.67, and that DF is degrees of freedom. That's if you needed the table. We'll talk about that when we do it in my stat lab. But mostly it won't ask you that. You aren't going to have to worry about it. So again, the things you would write down here is which test, what do you get for P? A decision. This we go right back to what we did in 8. So my P is 0.4998. My alpha is 0.05. That is less than, no. I must be getting tired. That is greater than, so 0.4998 is greater than 0.05. So I would fail to reject the null. Okay, and my claim was that it was equal to, that they had the same number of words per day. And I failed to reject because it was greater than, so there is not sufficient evidence to warrant rejection of the claim that men and women speak the same mean number of words in a day. So see, very, very similar to 8B, just 2 samples instead of 1 sample. Okay, next example there. You want to buy a vacuum cleaner and the salesperson tells you the repair costs for Model A and Model B are equal. You research the repair costs of 34 Model A vacuum cleaners and 46 Model B vacuum cleaners. The results of your research are shown in the table. At a significance level of 1%, a few times we haven't had 5%, can you reject the salesperson's claim? Alright, so very first question, is it independent or dependent? It's 2 different models of vacuum cleaner. So that would be independent. Okay, we got to write the null and alternative. I didn't leave myself that much room on this one. So I'm going to write over this just a little. Null alternative. Again, it gave it to you in a real nice little table. Again, it won't do that, so make your own nice little table. And they decided that Model A was the first sample and Model B was the second sample. And it wants me to test the claim that... What did the salesperson claim? It says, can you reject the salesperson's claim? Well, the salesperson's claim was that the repair costs for model A and B are equal. So it's just like our last one. He says that mean 1 is equal to mean 2. Opposite of that for the alternative would be not equal to. So we're going to see if he's right or wrong. Okay, I just got ahead of myself a little bit. Okay, so that's step 2. Oh, shoot. I had more room on that slide. So I'll just... Okay, so we got to decide what we're going to do. Again, we got all the stuff in that nice little table. This time it tells us that alpha is 0.01. We know sigma this time. So this time we really are going to be doing z-test. But because we have 2 samples, it's going to be 2 sample z-test. So if you go to that on the calculator, stat over to test, number 3, 2 sample z-test. You want to keep it on stats. The first thing it asks you for are those standard deviations. Well, the standard deviation for model A was 10, and the standard deviation for model B is 18. Then it goes back to the first sample and asks for the mean and the sample size. So the mean for model A was 50, and the sample size was 34. And for model B, the mean was 60, and the sample size was 46. I want not equal to, because that's what my alternative is. Calculate. And you get a P of 0.0016. So for step 3, 2 sample z-test, and P equals 0.0016. Make a decision. 0.0016, 0.01. Well, that P is less than that alpha, so I'm going to reject the null. Okay, B. So my claim was the null. I reject the null. There is sufficient evidence to warrant rejection of the claim. The mean repair costs for Model A and Model B vacuum cleaners are equal. So we do not believe that salesman. All our research tells us he was wrong. Alright, one more example. It says Capitril is a drug designed to lower systolic blood pressure. When subjects were tested with this drug, their systolic blood pressure readings in millimeters per mercury were measured before and after drug treatment, with the results given below. At the 0.01 level of significance, is there sufficient evidence to support the claim that Capitril causes a difference in the systolic blood pressure? So you got to decide, is it independent or dependent? Well, this one, it said before and after, and it said that each subject was measured that way. So these two measurements are for the same person. So that tells you that this is a dependent situation. Okay, and because it's dependent, we make one sample out of it by subtracting them. So we're going to go into L1 and subtract before minus after. So in your calculator, stat edit, and then type in 200 minus 191. So that you're taking the before for subject A and subtracting the after. And you want to do that for each one. So the next one would be 174 minus 170. And then 198 minus 177, and so on and so forth. So go ahead and do that for each one of those. So you're subtracting and creating one list in L1. Okay. So right now in L1 I have these numbers. 9, 4, 21, 3, 20, 31, 17, 26, 26, 10, 23, 33, and that's it. Okay? So then we're going to write the hypothesis and label the claim. Well, anytime you're doing a dependent one, because you're subtracting and you're testing the difference, you're always going to be comparing to 0. And that little mu d just is standing for the mean of the difference. It wanted to know, is there sufficient evidence to support the claim that Capotro causes a difference? Well, remember from one of the examples in chapter 8, if it's talking about does it cause a difference, that's not equal to. So you put under the alternative that mu d is not equal to 0, that's the claim. The opposite of it is equal to. Okay, so we know it's dependent. We know that alpha equals 0.01. So now we've got to figure out which test do we use. Because we only have one sample now, we're either going to use t-test or z-test. That depends on standard deviation. Nowhere in here does it say anything at all about standard deviation. So we're going to do t-test. And it's just t-test, not two sample t-test, because I took those two samples and made it one when I subtracted. Alright, so I've got t-test, go in the calculator, make sure I pick data, because I got a big old list of data in there. Your mu naught is 0, because that's what was in your h naught. Make sure it's in the correct list. Frequency should be 1, and you want not equal to, because that's what your alternative is. Calculate, and you get p equals 5.28 e to the negative 5, which is basically 0 plus. So you've got t-test, and you can put p equals 0 plus. Now compare p to alpha. So p equals 0 plus, alpha equals 0.01. That p is less than that alpha, so I'm going to reject the null. So my claim was the alternative. I'm rejecting. Claim is the alternative, rejecting the null. The sample data support the claim that. So the sample data support the claim that Capotro causes a difference in the systolic blood pressure. Alrighty, that's it. So like I said, just make sure that you get these notes finished. And we will do these step by step in class. And then we will start chapter 10. So this test is on 8B, 9, and 10.